Welcome, welcome, welcome. We were waiting for a few more people to come in, but I think we should get started. Welcome everybody to our Temporal flagship community meetup. We are so happy to have everyone here. Pop in the chat where you are tuning in from, and let's get a bit interactive. So I'm your host, Vanessa Rabankwa, the new community manager here at Temporal. And I am looking forward to today's webinar. Next slide, please, Rob. Great. So I have a few announcements. For those who don't know, the replay CFP deadline has been extended. The replay is our temporal conference, which will be hosted live and direct in Seattle from the 12th to the 14th of September. If you haven't already, please check out our CFP and grab your tickets because they're going fast. Next slide, please. And then we have an amazing range of upcoming events. So this month, actually on Thursday, we have our first in-person Seattle Meetup event. And then next month, we have Money 2020, which these are the conferences that we will be featuring in around the globe. So that will be in Amsterdam. And at the same time, we will also be at Domain-Driven Design. Oh, did something happen? I think page went down. That's so weird. Ah, okay. The page is coming back up. Technology, eh? Thank you, Rob. If you could just get the third slide up, please. I think he's having complications. So I think he's having a few complications. So I will continue. So then we have JCon coming up, and we also have we have Kansas City on the 22nd to the 23rd, and we also have GopherCon in Berlin. So we have an amazing range of events. Our agenda for today, if we get into it, is we have a 5-side chat with Jessica West and Spencer Judge starting shortly. And then we have our next session, which is Scaling Temporal with Rob Holland. So I will let them get into it. Welcome our first speakers, Jessica West and Spencer Judge.
Thanks, Vanessa. Hey, everybody. Hope you're doing well. Hey, Spencer. Nice to see you. Nice. Awesome. So for those that have attended this meetup before, you might see things a little bit different because we're doing a webinar. So we're trying a new feature from Zoom, but we have a Q&A area. So if you have any questions throughout this, just feel free to drop that in there and we'll make sure we'll answer those. So first one kicking off. So my name is Jessica West. I head up the developer relations and community team here at Temporal. And I'm really looking forward to hear. I've got Spencer Judge from the engineering team on the SDKs. And we're going to go through a couple of questions that I have. But if you have any questions that you'd like to ask Spencer, please drop them in the Q&A and we'll bring them in. So awesome. Spencer, hey, welcome. Happy Tuesday.
Hi.
Hi. Can you tell me about what area of focus you work on with the SDK team?
Yeah, definitely. So my area of focus for a long time and still in a maintenance capacity and in an adding features capacity is this core library we have that I wrote that backs all of our not Java and Go SDKs. So all of the relatively newer ones that we've made. And the reason that that exists is, for those of you who don't know, our SDKs are actually quite complex. They're not just sort of like wrappers around RPC calls. They have to do a lot of internal logic. And so, we knew that we didn't want to have to redo that logic over and over every time that we made a new language, because that would be a lot of time investment and B, like a potential source of bugs. So a little over, I guess more like 2 years ago now, when I first started, we embarked on this project to write this core library in Rust that all of these newer language SDKs would sit on top of. And I was the primary author for that, and I still maintain it. And that's kind of what powers like a lot of the internal logic of our newer SDKs.
That's awesome. Thanks for sharing. So from that, like, what does a typical day look like for you? In temporal land.
I mean, I think it kind of depends a lot. If there's something important that needs to get done in terms of like fixing a bug or adding a new feature to that library, that's oftentimes priority. But beyond that, I also work on sort of other features that might be cross-cutting concerns across a handful of things. So some people in the community might be familiar with, there's an effort to expose like a nicer way of doing some typical versioning patterns that a lot of people need to engage in when they want to work through changes to their workflow code. And so that's like been an ongoing effort for some time that I've been working on. And that actually primarily is changes to the server side rather than SDKs. So like that's a different thing that I'll be doing day to day. And then I also sometimes like have been in recent memory working with our UI team to try and figure out ways that we can like better visualize what's going on in workflow code, on our web UI that people use. So like sort of lots of different things. It kind of depends day to day.
Yeah, that sounds exciting that you get to kind of change things up and go into working with different teams across
definitely.
the board. Keeps things exciting. So I think from that, actually, like what do you enjoy most about being an engineer at Temporal?
Yeah, that's a good one. I mean, I think one of the things that's great about working here is just we have, I think, a really cool team. The people that I work with are pretty talented, and it's really fun to have a group of people that really like are excited about our product and are really knowledgeable technically and have things that they can teach me and things that I can teach them, and like just good collaboration in that respect. And then on top of it, like, the things I just described are cool from a technical perspective, like especially like about the SDK team that, we get to kind of work with a lot of different languages and touch different things. And that kind of checks boxes for me that I'm interested in. So that's really fun. And like I just mentioned, and you pointed out, kind of having like different stuff that I can be working on or looking at in any given day instead of sort of just like always doing the same specific thing. Like that's pretty rewarding too, right? Like you get to just have a little bit of variety and like some really just fun, broad experiences in terms of what you get to work on.
Yeah, that's awesome. Cool. And then I've got another question. Then I've got some coming in from the attendees, so we'll bring them up forward. But I think this will help lead in for some others. So with all these kind of projects you've looked at, doing cross-team collaboration, working at the different SDKs in different languages, can you, if you were to think about like a cool or like challenging project you've worked on in the past year with Temporal, either like directly or kind of collaborative, like can you tell us a little bit more about that experience?
Yeah, sure. I mentioned the working with the UI team recently. That's something that we haven't shared broadly externally yet, but will be coming up at some point. That's been really fun. It dovetails nicely with my background a little bit. I used to work at Tableau, which maybe a lot of people are familiar with, which is like a data visualization company. So I have some experience with, how do you help people? Well, Tableau's model is always like see and understand data, right? So how do you help people like look at something kind of complex and make sense out of it? And that's just been a really fun thing to do, like try and give a little bit of my input on that front and see what we can come up with in our UI that like is visual and interactive and helps people discover information that they need to know about what's going on with their workflow. Like, right now, if you go look in our UI, it's very text heavy, right? If you want to go look at the workflow details page, you see the history of your workflow in terms of these events, and that's just text. And that's very granular and like useful if you understand what's going on, but it's quite difficult to understand. So like humans are much better when we are presented with like a visual representation of data. So figuring out like how do we make that a little bit more visual? Like how do we, get your like lizard brain to kind of focus on the stuff that's important? That's been really fun and interesting. And like I think what we've been coming up with is pretty cool, and it'll be really exciting to get that out there and see how people respond to it.
That's awesome. Yeah. I love the kind of the visualization of data. It's like it can be so powerful, right? But if you can't see it or quite like dig through, it's really hard to say like, what can I do with this, and how powerful really is it if I don't quite understand it? And that visualization is so huge. So
yeah, and just like
cool
bringing your
about,
attention,
like, bringing it in.
Yeah, like and bringing your attention to stuff that you can't like an outlier, for example, right? Like if I give you a text table and like your distribution of data is like pretty normal, except maybe there's one extreme outlier, right? Like if you look at a text table with 10,000 entries, you're never going to see that outlier. But if I show it to you visually, it's like, oh, it's right there. So it's that presentation is just dramatic improvement.
Absolutely. Yeah. Awesome. Okay. So one of the questions that we have from the audience is going back to some things you were talking about originally when you were talking about your kind of day-to-day work and how you're working through those things. And I say, is there any benefit of backporting Go and Java SDKs to use the Core SDK?
Yeah, that's a great question. It's certainly one that we've talked about quite a lot internally. I mean, to answer it literally, yes. I mean, there's definitely benefit, but like there's also, things we have to consider, right? So the primary one is that the histories that you've produced with those existing SDKs would not immediately be compatible with like a core backed one. So, were we to do that and release it, there would have to be this transition period for any user who has like, especially if you have very long lived workflows, that might be running for years or whatever. You're going to have to kind of like, figure out this transition, which probably is not too painful, but is something to consider. Then beyond that, we've gotten a lot of feedback from people that we've talked to just in Slack or whatever. Not everyone who runs Go and Java is comfortable running things with native extensions. And right now, the way that the core library works is it's a native extension, right? It's compiled code that would have to be linked in or loaded up at runtime by Go and Java. And operationally, not everyone wants to do that. The cool thing there is that like we do have a solution for that, and it's something I've kind of been working on a little bit, but is not as much of a priority as the other things I mentioned, which is that if we get the core library to compile down to WebAssembly, which is something I know can be done, and I've made some progress towards too, but it's just a bit of an investment. If we get that working, we can actually load it up and Go in Java without any native extensions. And that could potentially be a really powerful way to get the core library into there. And then the benefits, I think, are fairly clear, right? It's just, okay, cool. Now everything is consistent and sort of works the same way. We fix a bug, we fix it everywhere. Just all those reasons that you would want to reuse code in the first place.
Yeah, absolutely. Just keeping those good best practices alive within our own area. Awesome. Thank you. All right, we've got another one. This is from Bruno. And Bruno's question is, will this visualization show activity retries or at least give a more glimpse into failures happening in the workflows?
Yep.
In reference to your most recent one.
Definitely. Short answer is yes. That's definitely something we want to make pretty like clear and obvious in the stuff that we're working on.
Awesome. Cool. So, and group, if there's anything else like you want to ask, please forward. So I'm going to make sure done. In the meantime, so let's see what other, I have so many other questions. I could just keep going on. So the group just like have me chatting. But one of the things is, so we talked about like what you've worked on for the past year, and you mentioned the UI team. Is there any other like really kind of challenging problem that you've had to work through that may not have had a solution, like an obvious solution right away, that you really had to dig in? and work through that you can chat about recently?
Yeah, I mean, there have been there's always stuff, right? The core library itself always has kind of interesting challenges. I don't know, to make the question a little bit higher level, like I think the types of challenges that I run into tend to fall into sort of two categories. Like stuff that's in the core library tends to be this type of problem that's like little intricate, like clockwork, detail-y problems, right? Like something like, oh, does the way that I manage a bunch of concurrent tasks like work the right way, and like have I synchronized them the right way, and does the performance you get out of that, is that desirable, or like is there potentially some bug in terms of overflowing the amount of resource sources you're allowed to use or whatever. Those are like very like zoomed in detailed little problems. And then there are kind of like higher level, more designy problems that come up in things like, for example, that versioning effort I'm working on, which is like, well, is this API going to be suitable for the questions our users need to ask? Like, are these concerns going to scale when we have, users using it on cloud across thousands of task queues, and those aren't like sort of zoomed into the code, like how do I make this particular little thing work, but are more, oh, how do we design this system so that it, has the right characteristics in the long run for, the ways that our users are going to use it. So there's there's always tons of challenges, and I think that's kind of a fun way to look at it, is like you get ones at very different granularities, right? And from a personal perspective, I think I kind of enjoy the really detailed little, like, just, zoomed in, like make the code do exactly the right thing problems. Because I feel like those are the ones that for everyone who's an engineer, I think you kind of get that feeling that's fun, where you're really just focused and you're able to kind of just, work for a couple hours and like have this really good feedback loop in this, kind of rewarding experience of solving little problems. So those are always fun.
Totally. Yeah. It's like I don't know if there's any like real greater feeling in the world of like, you've got a problem, you're going over and you just like, keep hitting the wall, and then it's solved. And it's, especially if it's great in the day, because then you're not bringing it home. But it's just like, it's like so rewarding and it's awesome and feels great.
Oh, for sure. And I would say my favorite tip for other engineers who, are maybe stuck on a problem like that or something. For me, if I feel like I'm just running into a wall and it's not working, I'll just go out and go for a run or something. And it is amazing how often it is the case that, you come back from being away for like an hour or something, and then you're just like, oh, it's easy. Like,
yeah, it's like the background process.
Yeah, totally.
Yeah, start working. It's awesome. Great. Okay, we've got a couple of questions from the audience, so I'll go back there. So does Temporal use workflows or dog food the technology in any business processes?
Yeah, absolutely. For me and the SDK team, not as much, because we sort of like ship boxed software, right? So there's not so many like services we're maintaining, things that like that. However, there is, for example, one project we've been working on that's like a load generator, whose goal is to both stress the backend and stress our SDKs, just sort of make sure that we find any problems that crop up under high load. And that thing is sort of explicitly designed where the scenarios that you write are written as temporal workflows. So you'd come along and you'd write a temporal workflow that's like, all right, I need to spin up such and such amount of temporal nodes. I need to spin up such and such amount of SDKs that are doing, these things, producing this kind of load, and then determine if, we're getting the right behavior that we want out of that. But other teams, for example, like our infrastructure teams who work behind cloud, I think like almost all their stuff is done in terms of temporal workflows, but I don't have the most knowledge about that.
Maybe we'll bring some of the infrastructure up in the next meetups. Awesome. Thank you. Another question we have from Brad Jones. Can you speak to the status of Nexus and Allo?
I wish I could, Brad, but that would be a great question. For example, my coworker on my team, Chad, he's been involved in Nexus pretty heavily, but I have not so much. So I don't want to misspeak about anything there.
see. I think Chad might be on here.
I think
So
he's on the
we'll
call.
go-
Yeah.
Yeah. Let's see if I can raise your hand. Hang on. Dude, Chad. I've got Chad and Ryland. Ooh, this is one.
Yeah, that would be the perfect combo.
All right, I'm gonna one perfect.
Hello.
Hey, gents, you're on.
All right. I feel like I'm calling into a radio show. So Nexus is still in its proposal design phase without a defined timeline, but we're applying resources now that we weren't before, because obviously we're busy with everything. So people should start to see it moving faster, but that's about all we have so far.
Yeah, I'd even say just a little bit more concretely, like it's firmly planned at this point. Like we have people set aside for it, and we have a real like internal timeline at least that we're happy with. Chad was kind enough to even kind of go through and mock out most of the client side experience, like even 6 months ago. And so really it's about getting like the server side resources to do the architectural design and then actually implement that in the server. So yeah, we're very positive about it, but yeah, no external timeline yet.
Awesome. Thank you both. Cool. All right, we'll go to the next question. So the next one is from Josh. And it says, if I have a workflow that needs to run 1 million activities and after continue aggregating the results, how would you structure that with child workflows? And then a follow-up also, how would you run the activities in parallel?
Cool. A little bit of support going on. It depends a little bit. Okay, so you mentioned the activities need to run in parallel. All of them, some of them at a time, which SDK depends a little bit. But so all of our SDK languages have some kind of support for running things in parallel, and typically it's done the way that you would normally do it in that language. So like in Go, for example, you might just spin up a bunch of Go routines and call the activities from there, right? Oh, he's mentioning Ruby, the Coinbase one. Okay, well, we don't even the Coinbase one is an R SDK. So I don't actually know off the top of my head how the Coinbase Ruby SDK expects you to do parallelism, but I think they probably have some kind of.
There is. You can send the token and then reply it back.
Yeah. Okay.
I think the main question is about the child workflows and with how do I spread it out, because I know there's a 50K limit of items and
yeah. So you're worried about the history limit and that sort of thing. I mean, I guess it depends a little bit on the order in which you want to do stuff. If the goal is just they all need to run and they don't really have any kind of sequencing,
they don't.
So I would say just you can just do a little bit of napkin math basically and fan out to the amount that you feel is appropriate, right? So like, you got a 50K limit per workflow. You probably want to stay a little bit under that just as a safety buffer. And then, fan out a bunch of children, have them do as many activities that would be appropriate in there, come back, get the results. And then perhaps even the main workflow would continue as new occasionally, just to make sure you're staying under that limit, right? Does that make sense?
I was thinking maybe like write one workflow and then like in a recursive way, call it like slice and then call the same workflow until I get to the small amount I want to run the activity.
Yeah. I think that's actually, that would be pretty cool. I think that's a reasonable way to do it. Yeah. I mean, alternatively, it perhaps is a little bit less complex for you to just sort of do the upfront math that I'm talking about, figure out, okay, well, I'm going to need this many children and I'm going to need to continue as new this many times or whatever, and just kind of chunk everything up front and then go to town.
So that's a bit optimistic for me, because 1 million is just a low assumption. It can be 100 million.
I see. So it's not exactly precisely fixed.
Yeah, exactly.
Yeah. Okay.
I wish it was, but sadly, no.
And in that case, I think your idea is pretty reasonable. I mean, that's kind of one of the things that we like about Temporal, right? Is there's certainly more than one way to get stuff done.
Yeah, that's cool. Thank you.
Awesome. Thanks, Josh. Okay, everybody. That was great Q&A. Thank you for all the questions, and thank you, Spencer, for answering everything and even going into detail with everything with Josh. I think from that one, it's our turn to exit the stage and pass it over back over to Vanessa and Rob. So thank you, everybody, for your time, and we'll see you next time.
Bye.
I really enjoyed that. Oh, it's good hearing sometimes more about the engineering team and different teams and colleagues that you don't get to interact with all the time. So that was really amazing. Maybe I have a career in engineering next. So next, I think we should be able to hear where moving into our next session, which is scaling temporal. I'm going to invite Rob Holland to the stage, my co-host from my side of the pond. Rob, are you around?
Hey,
Great.
how's it
Hi,
going?
Rob. I'll leave you to take over.
Okay, share my screen. Okay, can everyone see the slides okay?
Yeah.
Cool. Okay, hi, I'm Rob Holland. I'm a technologist at Temporal. I'm going to talk to you today about scaling Temporal. Yeah, let's get into it. So today's agenda, the talk will be about 20 minutes with some time for questions. I'll pause in the middle for some questions and then at the end as well. Yeah, so this is what I'll walk through. I'm going to describe the cluster a little bit, how I set it up, and then talk about measuring performance, scaling the history service. We're going to talk about optimizing polling. Spoiler alert, we're not going to get into scaling the matching service at this throughput level. We don't really need to, sort of out of the box, it's okay. If we have some time, I'm going to talk through a few Kubernetes tips that I've come across while I've been doing the benchmarking work, just to help you run Temporal on Kubernetes more efficiently, and then questions at the end. So the load test cluster. The cluster looks a bit like this. So you can see on the left-hand side, we've got the benchmark workers and the benchmark runners, and they're simulating what your application would do. So we've got the workers, which are running your workflows that you defined, and they can be in any SDK language. And then the runner at the bottom is a tool which will start a certain number of workflows. So I've configured it for 10 workflows in this case. And then it will wait for the workflows to complete and then immediately start another one. So for the duration of the load test, you'll have 10 workflows running all the time. You can also see the CPU requests and memory requests that I'm making for those pods as well, just to get an idea of scale. And then on the right-hand side of the diagram, we've got the temporal infrastructure. So we've got the history service, the matching service, which both sit behind front end, which is the service that your applications would talk to over gRPC. And then below history and matching, we've got the persistent state system, which in this case is MySQL, but that doesn't matter. And you can see it's 4 cores, 32 gigabytes for this database, just to give you a feel for scale. On the far right, you'll see the Temporal's internal worker, which runs Temporal's own internal workflows. There's not a lot to say about that for here. It's not an issue for scaling or anything, so that will fall off the slides shortly, just to get it out of the way, because we don't need to talk about it. So first thing we need to decide is how to measure performance. So we're going to talk about that a little bit. So there's 2 things that we need to measure here. There's the throughput, which is how much work we're able to do. And then there's the reliability. So it's very important that any throughput we have is managed, sort of handled in a reliable way, so that we have enough we have enough headroom to cope with spikes, and that any sort of spikes don't then knock on to other services either and sort of build up any back pressure or anything like that. And we also need to make sure that the application is responding Temporal is responding in a timely way, so that the application isn't waiting on the response from Temporal for requests. It needs to serve the application's sort of latency needs, basically. It's very important for throughput to be defined in a way that's not specific to workloads. And what I mean by that is it's important for the community to be able to talk about these things and sort of discuss scaling and optimizing things in a way that doesn't rely on the exact workflows they're running. So some workflows will complete a lot more quickly than others. Some might have one activity, some might have millions via child workflows and so on. So we need a term that's portable across all of those workloads so that we can sort of build knowledge around scaling and optimizing Temporal without getting bogged down in what workflows it's actually running. So the metric we're going to use for this is something called state transitions. Now, state transitions is basically a proxy for how many writes to persistence Temporal is doing to support durable execution for you. So anything to do with the matching service, for example, doesn't get included in this. State transitions is purely things that are adding direct value for you for your application code to make it durable. So that's what we're going to use. State transitions per second is going to be our throughput metric. And then for reliability, we're going to aim for all CPU and memory usage to stick below 80%. That's on the pods and the database. And then we're going to create service level objectives for the request latencies we care about to make sure that Temporal is configured in a way that matches our expectations from the application. So the first service we're going to talk about is scaling history. So this is what the cluster looks like, just to give you a reminder. There's 10 workflows running in parallel, like we said, so you can see that sort of bottom left of the slide or middle left of the slide. So that's where we're starting. And the first thing we're going to do is we're going to create an SLO, so a service level objective, and say, okay, our start workflow execution requests, which is sort of the primary request that you're going to be sending from your application to actually ask Temporal to do some work. We want that to be responding within 150 milliseconds. And we're going to say if that's not happening, then the cluster is not scaled well enough to handle the load in a reliable way. So we can see we've added an alert for this already, and it's failing. So the cluster is not in a state to service this in enough time. So you can see request latency graph on the bottom left there is sort of getting on for 350 at least, and we want it under 150, so it's way over. And you can see the alert on the bottom right as well. So why is this so slow? And the answer is we need to dig in and find out. Start workflow execution request is driven by the history service. So the request will hit front end will then talk to history, because the request is basically asking to start a new workflow execution history, which is handled by the history service. So what we find, we dig into the history dashboard and we can see the lock latency is very high, the shard lock latency, that's the bottom left graph. And so basically shards in the history service are a way of dividing workflows up across the history pods that we're running. And any write to any workflow within one shard needs to obtain the shard lock first. That's how we provide you the guarantees we do for durable execution. It sort of underpins all of that. So if you don't have very many shards, then all of your workflows are going to be fighting for the same few locks. They're going to be contended. Access is going to be very slow. Now, out of the box, the development settings give you 4 shards, which is only sort of suitable for testing and local development. It doesn't scale very well. So in a production system, we'd say the minimum number of shards you'd normally have is 512. It is important to note that you shouldn't go nuts and just set the shard count really high, because it costs you CPU and RAM on the history pods to manage this. And also we run some task queues, which are per shard on the persistence engine. So if you just set the shard count sky high, then it will add a lot of load to persistence. And so you may be maybe shooting yourself in the foot there. So you do need to be careful where you set it. And unfortunately, at the moment, you can only set it when the cluster is built. It can't be changed in Temporal at the moment. Hopefully that's something we might work on in the future. And there are ways to do it with migrating between clusters where you've built a new cluster with a higher shard size. But at the moment, once a cluster is built, you can't change the shard on that cluster. So what we're going to do, we're going to rebuild our cluster because we have to, as I've just mentioned. We're going to set it to 512 shards. And then we're going to start the workflows again and see what happens. So we can see great news to start with. Shard lock latency is now dropped down to 1 millisecond. So it's way under our, it's down a lot from what it was. It was down, it was 50, it's down to 1, so that's great. But we do notice a bit of a red flag. As I said, if you scale shards up, then the history pods need to allocate more CPU and RAM, use more CPU and RAM, because they keep caches for the workflow histories in that shard. So if you see the top right graph, you can see that the memory usage is climbing quite quickly. So the cluster was rebuilt at like 15:15, and it's been running about 10 minutes, and we're already up to sort of 25% memory use. So this is really bad if the if the pods run out of memory. What will happen is that one of the pods will be killed. Temporal will then try and rebalance the shards across the remaining history pods. When the pod comes back, because Kubernetes restarts it, it will rebalance again and try and spread them out again. And rebalancing is quite expensive performance, so we really want to avoid that. So it's very important when you're doing the scaling and tuning of your cluster that you pay attention to CPU and RAM limits to make sure, or RAM particularly, because you want to make sure that the pods aren't going to get killed by Kubernetes and restarted. So the only time, ideally that pods will be restarted is when you do a deploy. Sometimes a node will go down or whatever, and pods will be restarted, but you want to try and avoid it when you can. So we're going to bump the memory on our history pods. We're going from 1 to 8 gigabytes, and we'll see how that looks. Okay, so we've rebuilt, and as you can see on the right-hand side of the graph, memory graph now, the memory has basically, the ramp is a lot shallower, so hopefully that's bought us some room. We can keep an eye on it. and just see how we're going in a little while. But that should be good for now. Certainly, we've avoided the panic of pods being killed anytime soon. So coming back to our state transition metric, we're up to 395 state transitions a second. I can't remember if I said at the start, actually. Okay, so we started out at 150. When we were seeing the alert, I didn't mention the top left panel, I'm sorry. So when we were over our SLO for request latency and the alert was firing, we were running about 145, 150 state transitions a second. We've improved things. Our request latency is now under our SLO. It's at 50 milliseconds. SLO is 150, so we're doing very well there. And state transitions is now up quite a lot, so that's great. So let's add some more load now. We've got to a stable point. Let's try pushing it harder. We're going to up 10 workflows to 20 workflows. We add, and now we're up to 680 state transitions in a second. We've kind of got that for free by the looks of it. Request latency hasn't spiked. We're still feeling good. So let's up it again and let's just see what happens. So we up it to 30 workflows in parallel. State transitions has risen a little bit more, so not as dramatic as the first bump, but still pretty good. So we're up to 850. We've got a little bump in request latency, but we're still well under our SLO, so we're not concerned about that. So that's still looking good. However, digging back into the history dashboard, we can see that we now do have high CPU. So as I said, we're aiming for under 80% to give us that headroom that we need to survive a spike. So we need to do something about that. So we're going to scale up the core requests on CPU requests on the history pods. We're going to ask for 2 cores instead of 1. That's dropped the CPU back down to under 80%. You can see that the workflow lock latency has dropped as well as a nice side effect. And now we're looking good again. So we consider that stable. That's bumped our state transitions back up again, up to 1,200 now from initially about 150. So it's looking fantastic. All this Kubernetes side of things, the pods and everything looks stable. And our request latency, which had risen slightly recently, has now dropped back down to 50 milliseconds and looking stable. So that's really good. So I'm going to take a quick pause here and just see if there's any questions that anyone has so far. Okay, so Josh says, based on which object should we estimate how many shards we need? Based on how many workflows activities we run or something else? So this is really tricky. The answer, unfortunately, is that there is no good answer without testing. So I'm trying to get a feel for state transitions per second mapping to shards, but it doesn't always work that way. So basically, shards is a control which tells you how many workflow histories you can write to in parallel. It's the maximum number of workflows that you could write to in parallel. So if, for example, you have thousands and thousands, millions even of workflows, but most of them are sleeping, and so they're going to wake up every month and sort of charge someone's credit card or something as like a subscription stuff, then they're not actually going to be needing to write concurrently to the database because they're going to be sort of, although they're active in the sense that they're currently running, they're not doing any work. So the shard count is basically allows you to say how many workflows do I need to be writing to history at the same time, like actively doing work, recording durable execution progress, and that kind of stuff. And that's why we're recommending benchmarking, basically. There's a blog post out today, which I've written on this subject, which is what this talk is based on, which goes over some of this. But we highly recommend testing your real production workflows rather than these synthetic ones, and seeing how hard it pushes Temporal when you try and run the kind of counts that you want. So hopefully we'll be able to give you better answers as we sort of learn better abstractions. But at the moment, it's basically, we strongly advise that you do your testing yourself on your infrastructure with the workflows that you want to run to try and get a feel for it. Okay, so next question from Bruno. Rebuilding the cluster means redeploying all services after changing the number of history shards. Yeah, it does. So basically, I have scripts that do this for me, but basically I tear down the database and then I stop all of the services in Kubernetes. I bring the database back up, migrate it again, and then bring all the services back up. So yeah, you do need to, I think technically you can leave the services running and just like failing to connect to the old database, if you see what I mean, but the effect is the same. So yeah, everything needs to be restarted to make sure that the shard change takes effect. What metric backs the state transitions per second graph? It's a slightly weirdly named metric. It's state transitions count, which looks wrong, but is actually the right thing. So basically, we have a metric which records the number of state transitions in a workflow. So every time a workflow makes some progress and it's added another state transition, we record the progress of that workflow state transitions as a histogram. So that's not what we want, because we don't want to sum all of the total state transitions, because it's kind of a meaningless number in this context. So what we do is we count the number of metric emissions for state transition counts that we have per second. The metrics are all included in the blog post, which is on the blog today, so you can go and have a look there as well. And if anything is not clear, obviously, give us a shout and we'll help you out. What are you? This is going to sound a bit repetitive. Sorry about this, but what are you using for the benchmark runner? So it's a very small tool that I've written as part of the benchmark workers package, which is public on GitHub under the Temporal org. It's also linked to from the blog post. So almost everything I say in this talk is included in that post, including links to things and the metrics, for example, all of the Prometheus queries. And that kind of stuff. So yeah, hopefully that answers your question, but it's a very small, very easy to use tool. The defaults out of the box will get you something running, which you can then work on sort of scaling up and optimizing and configuring. But that should get you started. What was the CPU on the DB during running the benchmarks? Under 80%, bit of a spoiler. There is a slide at the end. We didn't get even close to 80% until a bit further on. But yeah, it was under 80%. It's a great question. I perhaps should have included a check on that earlier, but it was meant to sort of surprise at the end, which I've just ruined. So yeah, there we go. Okay, so that's the end of the questions for now. So I'm going to carry on. Yeah, optimizing polling. So we've got the history service scaled. State transitions is looking really good compared to where we started. Everything's happy on Kubernetes. Now, as I said, we're not going to talk about scaling matching, because that kicks in at higher throughputs, and that's something I'd like to explore in future posts. But for now, we are going to talk about optimizing polling, because it's a way to eke out the best performance out of the workers you've got and the sort of temporal infrastructure as well. So we're going to add our next SLO, and that's going to be on schedule to start latency. We do this for both activities and workflows because they're polled for separately. So again, we're going to set 150. Basically, for those who aren't familiar with the metric or the concept, the idea is that once Temporal decides something needs to happen because you've asked for it, then there's a timer started, and we stop that timer once the activity or the workflow task starts being acted on by a worker. So we've gone through the polling system, the worker's received the work, and it starts making some progress. So that's the scheduled start latency. So if you imagine that a application sends a start workflow execution request to Temporal, it's the delay between that request being acknowledged and the workflow being started and the worker actually making some progress. Or a workflow asking for an activity to run, and it's that gap between the workflow saying, I want this activity run, and the activity starting to run. So to get sort of good performance out of this, it will vary heavily per use case. People doing batch stuff, they can have very high scheduled start latencies because they're in no rush. They're expecting to put loads of stuff into the queue and then slowly work down it. But for kind of more steady state stuff like we're doing here, then we want to sort of get a responsiveness from our application. So we expect that if we start a workflow, it will be started nearly immediately. So that's what we're looking at. So we've added the SLO. We can see it's failing. We were going for 150 ms. And it's averaging quite a bit over that. We've also got poll sync rate on the left, which I'll talk about in a sec. So the first thing we want to do is we want to try and get that schedule to start latency down. Now, the reason it's slow at the moment is because we don't have enough pollers pulling work off the task queue. So as the workflows are making progress, we're asking for activities to run and that kind of thing. There's not enough people listening for work to take it off the task queue to get it started quick enough. So there's a bit of a backlog. So we're going to tune the configuration for our benchmark worker. We're going to double it. So we're going to add 10. We're going to go from 10 activity pollers and 10 workflow pollers to 20 of each. Sorry, it's the other way around, actually. So workflow pollers first, activity pollers second. I'm going to check the graph again. Okay, we can see now that if you look at the left-hand side of the graph, you can see that now the peaks have reduced, but we're still over our SLO. So it's progress, but it's not enough. So now we're going to whack these numbers up. And out of the box, I think the Go SDK has 1,000 slots for execution. So, we can happily rack up the polar numbers without any cause for concern at this kind of level. So we're going to go to 100 and 100. Okay, so we can see that our SLO now on the right-hand side is basically down to 50 milliseconds. So our scheduled to start latency, is down to 50 milliseconds. So way under SLO, looking really good, really happy with that. So let's talk a bit about poll sync rate. So ideally, in the matching service, all the tasks that need to be run are going to be held in memory, and a poller is going to come in and say, I've got some free time to do some work. Can you give me some work? And the matching service is going to be able to match that from memory, and everything's going to be really speedy because nothing has to hit persistence. So poll sync rate is a measure of how many times a polling request was able to be served from memory, basically. The flip side is if there's not enough workers pulling work off the queue, or enough pollers, I should say, then the matching service is basically going to decide that it can't keep this task in memory anymore because it's going to run out of memory. So it flushes it to persistence, and then it will load it back later and mix it in with tasks from memory. And that's async matching or async polling. So poll sync rate means that the latency is much quicker because we're not having to go to and from persistence. And it also means that there's less load on the persistence database. So ideally, you want to be above 99% for poll sync rate. And that means that you're working mostly in RAM. You're not having to send stuff to and from the database, and everything's going to run a lot quicker. As you can see, sort of the correlation here between poll sync rate going so much higher than it was and our latency dropping. It's because stuff's being able to be served from RAM a lot more quickly. As I say, ideally, we want that even higher. We want 99% or more for poll sync rate so that things are running really smoothly. So we're going to rough our workers again. If you see on the graph here, the workflow poll sync rate is looking pretty good. It's almost 100. So we're not concerned about that. Poll account's probably fine there. What we are going to do is up the activity poll account. I'm not going to show you another dashboard here, but I checked them. It didn't make much difference from 100 to 150. It didn't fix the problem. So what we're going to try instead is we're going to double the worker count. So we're going to go from 2 to 4 and see how that makes, what difference that makes. And then you can see the poll sync rate skyrockets basically, and then sticks at way over 99%, looking really good. Scheduled to start latency has dropped even a little bit further, and so that's the polling system optimized. Everything under our SLOs, and we should be serving everything basically from RAM on the matching service. At higher throughputs, you need to start thinking about scaling matching, but at this kind of level, you don't. It's fine as it is. Future posts. So state transitions, which is where we started, up to 1,350 now from 150 when we started. So I think that's really fantastic for these simple changes to get to that point. And then database CPU, as I mentioned before. So database CPU under 80%. If it's getting higher than that, you need to either think about reducing the load or updating the database size. Temporal scales horizontally. So the bottleneck almost always ends up being persistence because you're constrained by the hardware of whatever database system you're using. And although you can scale up all the temporal services, it's harder to scale the database, and they don't tend to scale horizontally, with some exceptions like Cockroach, for example. Okay, doing okay for time. I think I might go to Q&A first, and then if I have some time, I'll come back. The tips I was going to mention are going to be available in a post soon, so you're not missing out, so to speak. Where's the Q&A gone?
I don't think there's any Q&As, any questions
okay.
right now, Rob.
Oh, I saw the chat icon and thought it was the Q&A thing. Yep, my bad. Okay, so let's quickly run through this. So Kubernetes tips for temporal. These are things that I noticed while doing the benchmarking. The first one being the most dramatic. Temporal is written in Go, and Go has a setting called Go max procs, which controls how many processes Go starts to spread your threads effectively across multiple processes. Unfortunately, if you're deploying on Kubernetes, Go will think it has access to all of the processes that it can see on your node. And often that's not the case because you set CPU limits, or at least expect it to use less than that. So you get what's called CPU throttling. And CPU throttling is basically when Kubernetes kicks your process off the CPU because it's using too much. And that can delay things like obtaining locks and add latency to request handling and that kind of thing. So it's basically bad. The other thing I'll quickly mention is that, as I mentioned earlier, the history and matching services do rebalancing when pods go away or come back. And that has a cost to latency because while the shards are being moved around, they can't be written to. So you want to try and avoid slow trickle deployments when you're doing temporal rollouts, not with your workers, I mean, but with the matching and history services. So definitely worth experimenting there and seeing if you can make the deployments go in sort of bigger, fewer batches, if that makes sense. So if you've got 10 nodes, for example, 10 pods, you might want to do 5 and then 5 rather than the defaults, which is like 25% at a time, basically. So just to give you a quick example of what I mean with CPU throttling, the top left graph here, you can see CPU throttling, which is the red line at the bottom. Now, this is one of the things that really caught me out because I kind of expected that if the CPU metrics weren't hitting 100%, as you can see, they're not even, like they're averaging 40 maybe for the top one and 10% for the bottom, you shouldn't get any throttling. The reason this happens, it's quite surprising, is that the throttling time slice is only 1/10 of a second. So if your CPU spikes during that 1/10 of a second period, then it will be throttled back down and not allowed until the next cycles. Even though over the sort of 15-second period that Prometheus uses for its scrape interval, your average CPU usage out of what you're allowed is much lower than 100%. So throttling can still catch you. You need to monitor it for it specifically. There are metrics that detail throttling in Kubernetes. I'm using the Prometheus stack here, but most of the monitoring systems, Kubernetes will show you this. And you can see the problem at the bottom that I was mentioning. GoMax prox is defaulting to 8 because that's the number of cores that my test nodes have, even though I've set the CPU limits, well, requests to 2 or 1 to start out with. So I want to kind of get rid of that. So you should set GoProx manually on your pods, on your containers, to the number of CPUs you'd like Go to use. And that also makes Go more efficient if you're not taxing the CPU very hard, because Go has to run garbage collection and so on the various CPUs. If it's trying to do that on 8, then it's a waste of time if not all of those cores are being used, processes are being used. The next release of Temporal will automatically set GoMax prox for you if you set CPU limits on Kubernetes. Not everyone does. I kind of recommend that you don't, and I'll go into that on another post at some point. But if you're not setting CPU limits, you should set GoMax prox yourself. You'll get much more efficient CPU out of it. You can Google for it. It's really important to do that. So just wanted to mention it to get more efficient CPU usage of the temporal services when you're running Kubernetes. And the two settings that are useful to play with for deployments for the matching service and history service particularly are the max surge and max unavailable, which controls how many pods Kubernetes is allowed to take down and start up at once. And like I say, you probably want that window where pods are being moved around to be as short as possible, because it means the rebalancing will run quicker. And it can take about 1 minute or 2 minutes after the pods stop moving, I think, for things to balance, to finish balancing. So yeah, definitely experiment with that on your infrastructure as well and see if that can save you some latency when you're doing upgrades or when nodes die for temporal. And that's it. Any questions? Oh, sorry, I should just say, this is me fixing GoMax prox with this setting manually. And there you can see on the graph, the CPU has stopped being throttled. And we can also see that CPU usage is reduced because it's not doing all this garbage collection and so on the other cores. It has basically allows it to be much more efficient with the CPU that it has. Any questions? Cool. Thank you very much.
Great. Thank you so much, Robert. You've even brought the sun out, so that's great. Thank you so much. Guys, that was a great temporal flagship meetup. Would you agree? Also, if you would like to stay connected in the box, you should see now up here in the chat. Please continue the conversation in the Slack, and we will see you on the 20th of June. Thank you very much, and see you next time. Bye.